Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And as promised, in this video we're going to look at part 2 of exponents for mathematics grade 10, and that is how to solve exponential equations. Let's start. The first type of equation you will find is where you've got a power which is equal to a number. So what you do is you express the number on the right hand side as a power with the same base as the number on the left hand side, the power on the left hand side. So therefore that gives you 3 to the power of x plus 1 equals 2, and we express 9 as 3 to the power of 2. Now you've got powers of the same base equal, you can equate the exponent. Therefore x plus 1 equals to 2, and you now solve as you would any other equation. Therefore x equals to 1, and that's a solution there. Example number 2 is when you've got a similar situation but you've got equals to 1. Therefore, we go 3 to the power of t equals 2. Remember, 1 can be expressed as anything to the power of 0, so we choose 3 to the power of 0 in this case, and therefore your t equals to 0. Easy peasy there. And you're done. Next example is when you have a scenario like this with a plus in separating the two. So what you do is you break up all the powers into individual powers. So that is therefore 5 to the power of t plus 3 times 5 to the power of t times 5 to the power of 1. That's how you break that up there, equals to 400. Therefore, now you have a common factor, 5 to the power of t. So you take that out, 5 to the power of t, and you're left with, in bracket, that is 1 plus 3 times 5 to the power of 1, which is 5 over 400. If you need any help with factorization, there's a video that I made. Please go through that video on how to factorize for grade 10 and the channel, and learn how to do that. And on that note, please also don't forget to click the subscribe button and click the notification bell so you don't miss out on any new videos we upload in the future. Excuse me, that is 3 to the power of 5. 3 times 5, that is 15, not 16. Therefore, 5 to the power of t is equal to in bracket 16 equals to 400. Now divide both sides by 16. Divide both sides by 16 to get rid of the 16. And therefore, the 16s cancel out on the left hand side, and you're left with 5 to the power of t is equals to, now you take out a calculator, you go 400 divided by 16, that is equals to 25. So now express 25 as a power of 5, so that is 5 to the power of 2, and now your t is equals to 2, and your answer is 9. Now, an example like this is what we call a quadratic exponential equation. First of all, I want you to notice something. 3 to the power of 2x is simply equals to the square of 3 to the power of x. Let me show you. 3 to the power of x squared is equals to 3 to the power of, when you raise a power to another power, you multiply the exponents, and that's what we have there. So that is 3 to the power of 2x. So yes, this is simply just the square of that. So you go, let k equals to 3 to the power of x using the k method, and therefore now we express that any 3 to the power of anything as k. So that will be k squared minus 80 times k minus 81 equals to 0. Now it's easy to factorize. Unlike with the first format, that was a nightmare to factorize, equals to 0. The factors of 81 that will give you 80 in the middle are 1 and 81. And then we've got plus 81 minus 1. No, we've got minus 81, sorry. Minus 81 plus 1. Minus 81 plus 1. And therefore, you now solve as normal. K minus 81 equals to 0, or k plus 1 equals to 0. Therefore, k equals to 81, or k equals to negative 1. But we're not solving for k, we're solving for 3 to the power of x. Now we change back. Therefore, 3 to the power of x equals to 81, or 3 to the power of x equals to negative 1. Notice that this is invalid. This is invalid. There is no way this power can be negative at any point in time. Therefore, that's what makes it invalid. There's no number that you can substitute for x that will give you a negative number. Therefore, 3 to the power of x, now we express 81 as a power of 3. That is 3 to the power of 4. Now that you've got powers of the same base equal, you simply equate the exponents. So x equals to 4 is your answer there. And that is the only solution. So therefore, x equals to 4 is the only solution. And that is your answer there. Next type of question is a similar one, that is also a quadratic equation type of. Now let me show you how that is a quadratic equation. P to the power of a half all squared equals to p to the power of a half times a half, times 2, sorry, times 2 over 1. The 2's cancel out, and that leaves you with p to the power of 1, which is simply equals to p. Meaning that p to the power of p is simply the square of p to the power of a half. So you let k equals to p to the power of a half. Now you substitute. Therefore, p becomes k squared minus 13k plus 36 equals to 0. Now you factorize. Equals to 0. Now 36 times 1, okay, we've got 12 times 3. We also have 18 times 2. We have 9 times 4 and 6 times 6. The factor pair that will give us 13 in the middle is 9 times 4. That is the factor pair. So we use that one. We go 9 and 4. Both of them are negative because when we multiply them together, we must get a positive 36. So therefore, you now solve normally. K minus 4 equals to 0, or K minus 9 equals to 0. Let's clean this there. Therefore, K equals to 4 or K equals to 9. We're not solving for K there, we're solving for P. So let's revert back. Therefore, P to the power of a half, P to the power of a half equals to 4, or P to the power of a half equals to 9. Now, in order to solve this, what you do is you raise this P to the power of half all to the power of 2, but what you do to the left hand side, you must do to the right hand side. You square them. Or P to the power of a half equals to 9. You also square this. Therefore, you have P is equals to 4 squared, that is 16, or P equals to 9 squared, that is 81. And that is your answer there. Another example is when you've got a equation like this that looks like a linear equation or a linear exponential equation, but upon closer look you will see that it's actually a hidden quadratic equation. Let's see. Let's start. So the first thing you do is you break everything up into its individual powers. That's minus 2 to the power of 4 times 2 to the power of negative x equals to 0. Now take the 2 to the power of negative x below. That becomes 2 to the power of x. Now notice that now you can multiply throughout by 2 to the power of x. But to make your life easier, just let 2 to the power of x equals to k. Let k equals to 2 to the power of x to make your life easier. Let k equals to 2 to the power of x, and you will see how things become easier. Therefore, substitute back k. Minus 2 to the power of 4 is 16 over k equals to 0. That's what that equation should look like. Therefore, multiply throughout by k. That is k squared minus 16 equals to 0. Now you've got a difference of 2 squares. Let's factorize that. Okay, we've got k and k, 4 and 4. One is plus and the other is minus. Plus and minus. Therefore, k minus 4 equals to 0, or k plus 4 equals to 0, meaning that therefore k equals to 4 or k equals to negative 4. Remember, we're not solving for k, we're solving for 2 to the power of x, so we revert back. Therefore, 2 to the power of x equals to 4, or 2 to the power of x equals to negative 4. Notice that there is no way 2 to the power of x can be a negative 4. So that is invalid. And we are left with 2 to the power of x equals to, now we express 4 as a power of 2, that is 2 squared. Therefore, x equals to 2 is the only solution. Last example, you have a situation where you've got a difference of 2 squares, a difference of 2 cubes over here. This one cannot really be factorized, right? But let's see how we go about this. 27 to the power of x can be written as 3 to the power of 3 all to the power of x, which is 3 to the power of 3x. So let's do that. Therefore, 3 to the power of 3 all to the power of x minus 1 all over 9 can be written as 3 to the power of 2 plus 3 to the power of x plus 1 equals to minus 8 over 9. Therefore, we've got 3 to the power of 3x, 3 to the power of 3x minus 1 all over 3 to the power of 2x plus 3 to the power of 2x plus 1 equals to minus 8 over 9. Now when we factorize the difference of 2 cubes, notice that 3 to the power of 3x is simply equals to 3 to the power of x cubed, which is equals to 3 to the power of 3x. Same with 3 to the power of 2x, it's 3 to the power of x all squared. So now let's continue. Let's factorize the difference of 2 cubes. But before we do that, we let our 3 to the power of k equals to 3 to the power of x. Now, therefore, we have, therefore, k cubed minus 1 over k squared plus k plus 1 equals to negative 8 over 9. Now we can factorize that easily. K minus 1, k squared plus k plus 1. If you need help with factorization, please consult the video that I made on how to factorize for grade 8, for grade 10. Alright, now these two cancel out and you're left with k minus 1 equals to negative 8 over 9. You multiply throughout by 9, you get, therefore, 9k minus 9 equals to negative 8. Take all the numbers to the right hand side. Therefore, 9k equals to, taking this to the right hand side, it becomes 9 minus 8. So that becomes 9 minus 8. Therefore, 9k equals to, 9 minus 8 is 1. Therefore, k equals to 1 over 9. But remember, we're not solving for k. We're solving for 3 to the power of x. So we'll revert back. Therefore, 3 to the power of x equals to 1 over 9. But 9 can be written as 3 to the power of 2. So that is 3 to the power of x over 1 over 3 to the power of 2. Therefore, 3 to the power of x equals to, let's take this to the top. It becomes 3 to the negative 2. 3 to the power of negative 2. Therefore, now that you've got powers of the same base equal, we can simply equate the exponent. Therefore, x equals to negative 2. And that is your answer there. We've come to the end of the video. Please, thank you very much for watching. I'll see you in the next video.